Welcome to The Explainer. So today we're diving into what might just be the most important object in the entire world, the microchip. Okay, let's just start with this quote because it really says it all. This comes from Japanese policymakers and it perfectly captures the stakes. See, we're not just talking about what's in your phone. This tiny little piece of silicon, it's the foundational staple for every single modern industry on the entire planet. And because of that, the market for these critical components is absolutely exploding. I mean, projections show it rocketing towards almost $200 billion by 2030. And it's all driven by this insatiable demand for AI, 5G, and cloud computing. But here's where it gets really interesting. There's this wild paradox at the heart of the industry. On one hand, we're on track to sell over 1 trillion of these cheap, everyday commodity chips. But on the other hand, you've got just a few million of these high-end AI chips. And get this, they're projected to be worth nearly as much as that other trillion combined. So what does that mean? Well, that immense, concentrated value has turned what used to be a technological race into a super high-stakes geopolitical war for control over the world's most critical resource. And this isn't the first time we've seen a chip war. Dominance has shifted dramatically over the decades. The US-China rivalry happening right now, it has some serious echoes of the intense trade friction between the US and Japan back in the 80s, when Japan for a short time became the world's biggest supplier.
Today, though, the conflict is dangerously focused on one single place, the island of Taiwan. And that's because a single company there, TSMC, provides over 1/3 of the world's entire new computing power every single year.
And this right here, this stat brilliantly illustrates the risk we're all facing. TSMC alone has almost the same market power as the entire OPEC cartel. I mean, think about that. That level of concentration in one company, in one location, is just completely unprecedented for a resource this critical. This geographic vulnerability, it creates a single point of failure for the entire global economy. It's why experts warn that a conflict there wouldn't just be a problem, it would be a catastrophe, one unlike anything we have ever seen before. Now, while Taiwan totally dominates the manufacturing side, the design of these chips, that's concentrated in other places. Israel, for example, has become this crucial R&D hub. It's a place where giants like Intel and NVIDIA go to design their most strategic and valuable silicon. But the source material also presents a conflicting point of view here, and it's important to understand. There's intense ethical criticism of this ecosystem. You have movements like boycott, divestment, and sanctions, or BDS, arguing that the sector is a pillar of what they call an apartheid economy, and that it's deeply tangled up with military and surveillance operations. Okay, so let's move to the next layer of pressure, because this incredible industry is hitting literal walls. The walls of physics, and at the same time, the absolute limits of our planet. So for decades, you had Moore's Law, right? It famously predicted that chips would just keep getting exponentially more powerful. Well, that law is dying. As we shrink transistors down to the atomic scale, we are slamming into these 3 fundamental physical barriers that are just incredibly, incredibly difficult to overcome. And trying to overcome these physical limits, it comes at a truly staggering economic cost. Designing just one of the next-generation advanced chips is projected to cost upwards of $725 million for one chip design. And then there's the massive, hidden environmental cost. Chip fabrication is unbelievably water-intensive. A single factory can burn through 10 million gallons of ultra-pure water, not in a year, not in a month, but every single day. That's enough to supply a small city. And at the very same time, the huge AI data centers these chips power are putting this unprecedented strain on our global energy grids. By 2027, they're expected to require an additional 92 gigawatts of power that, frankly, we may not even have. So, with silicon at its absolute limit, geopolitics at a boiling point, and our planetary resources stretched thin, where in the world do we go from here? Well, the answer might sound like something straight out of science fiction. The solution to this whole immense pressure cooker of problems, it might actually involve leaving silicon, the material that literally defined the last 50 years behind, entirely. One of the most radical alternatives is something called graphene. It's this incredible material that is literally one single atom thick, and its unique electrical properties could completely revolutionize processing speeds while using way, way less power.
But the most mind-bending future is what's called biological computing. In a project known as DishBrain, scientists are literally fusing living human brain cells with silicon hardware, and they are teaching these neurons in a dish to play video games like Doom. No joke, this is real, and it actually demonstrates that biological tissue can learn.
And that brings us to our final and maybe most provocative thought. After a century of building our machines with metal and silicon, we may be on the verge of learning how to grow them instead.